Pantothenic acid, vitamin B5, does not generate the research excitement surrounding vitamins D, B12, or K2, and it rarely appears in wellness discussions about autophagy or cellular health. This relative obscurity is partly earned by its ubiquity. B5 is present in virtually every whole food to some degree, and frank deficiency in humans eating any reasonably varied diet is rare. But rare deficiency does not mean optimal status is universal, and in the specific context of fasting, ketogenic dietary patterns, and the lipid-dependent aspects of autophagy, pantothenic acid's role as the essential precursor for coenzyme A becomes more consequential than its low-profile status suggests. Coenzyme A is the central molecule of lipid metabolism, the compound to which fatty acids must be attached as acyl groups before beta oxidation can proceed in the mitochondrial matrix. Every molecule of acetyl-CoA that enters the citric acid cycle and every ketone body produced from fatty acid metabolism requires CoA, and CoA cannot be synthesized without pantothenic acid. During fasting and caloric restriction, the states that most robustly induce autophagy, the cell's energy substrate shifts from glucose to fatty acids and ketone bodies, and CoA demand increases substantially as this metabolic switch occurs. The autophagy process itself generates fatty acids and other lipid components from the breakdown of cellular membranes and organelles during autophagic degradation. And these components must be processed through CoA-dependent beta oxidation to generate the ADP that powers further autophagy operations. This creates a specific functional requirement. During periods of fasting or carbohydrate restriction, when autophagy is most active and fatty acid oxidation is most heavily relied upon, pantothenic acid requirements may be higher than in fed states, and ensuring adequate B5 status becomes more relevant as an autophagy-enabling nutrient. Liver is the standout dietary source at 8.3 milligrams per 3-ounce serving, followed by shiitake mushrooms at 2.6 milligrams per cooked cup, avocado at approximately 2 milligrams, and chicken breast at 1.3 milligrams. The adequate intake is set at 5 milligrams daily for adults, a level most diets meet. But individuals eating very restricted food variety or following medically supervised protocols may benefit from attention to this often overlooked B vitamin. The synergy with other B vitamins is direct rather than metaphorical. Riboflavin, B2, is required as a coenzyme for fatty acid beta oxidation itself, meaning that B5 and B2 work in concert to process the lipid substrates that autophagic degradation generates. Thiamine, B1, supports the pyruvate dehydrogenase complex that produces the acetyl-CoA that converges with CoA in the metabolic network. These interactions underscore why addressing individual B vitamins in isolation or supplementing one while neglecting others produces incomplete results in any metabolic context, including autophagy optimization. For people implementing intermittent fasting protocols specifically to enhance autophagy, ensuring robust B-complex status across all 8 B vitamins before and during fasting periods is more physiologically sound than fasting with nutritional gaps that limit the cellular machinery from performing the cleanup the fast is intended to promote.